All right, we're going to multiply a polynomial by a monomial. And so what that looks like is we have some polynomial. Let me give a specific example. 2x cubed times y. Now I'll put my polynomial in parentheses here. 2x plus 3xy. Let's just step back and look at that we have some parts here. Our monomial has one term, one part. So I'm just going to say, hey, in my mind, that's a. And my polynomial has two parts, separated by the plus sign. So I'm going to look at the first part as being b, and the second part as being c. Well, we have a distribution rule that said that we could distribute a to both parts here. We end up with a times b plus a times c. This is happening underneath our polynomial. We can take our monomial, 2x cubed times y, and multiply it to the first term of our polynomial plus our monomial again times the second term of our polynomial. So we've converted a multiplication of a monomial times a polynomial into two monomial multiplications. Plus sign still separates two terms, so we're going to end up with two terms when we're done. But we get 2 times 2 x cubed times x times y cubed plus 2 times 3 x cubed times x y times y. I apologize here. Again, I think having to reset the computer earlier, I'm rushing a bit. That is not y cubed, that's just a single y. So let's look at this again here. I take my monomial and I multiply it by each term of my polynomial up here. This gives me this term here. Now I bring the 2's up front, and then I put all the x's together, and then in my lowly y. And I repeat that over here. So I have 4, scroll this up a bit here. There we go, make it visible. 4 x to the 4th y plus 6 x to the 4th y squared. Now notice these terms are not the same. In fact, if we were to write this in descending order, we'd write 6x to the 4th y squared plus 4x to the 4th y, because this is a 6th degree term and this is a 5th degree term. And this keeps this in descending order. But the process distributes out, and multiplying a monomial across a polynomial usually gives you as many terms as your polynomial had. We'll look at another example here. And we'll look at 4x squared y times x squared plus xy plus y squared. Now notice we have a longer polynomial here. It's not a binomial in this case. Distribution still works the same. This monomial is going to get multiplied by each term. And so we'll make each term get a separate color in this distribution. I'll eventually figure out how I want to play with this rainbow I have off on the side. But for now, I'll do the red terms. So it's 4x squared y times the first term, which is x squared, plus, yeah, my plus sign looks like a demented T. Let's do that again. There we go. And now I use turquoise, so 4x squared y times xy plus my last term here. So 4x squared y times y squared. Using my exponent rules, I get 4, whoops, let me get my solution color right. See, I'll get this color thing down. 4x, now I only have two x terms here, they're both squared, so my exponent rule, x to the fourth, and a single y, plus 4, I have an x and a single x, that's x cubed, and I have two y terms, y squared. 4, I only have one x term here, so that's x squared. And then I have my invisible one on this y here. The 1 didn't show up. Let's make that a 1. There we go. And a y squared, so that's y cubed. So I've taken a monomial times a polynomial, and I turned it into 3, because our polynomial had 3 terms, monomial multiplications. Then the rules of monomial multiplication continued through. And this is multiplying a polynomial by a monomial.